Problem 3, using linear regression. And this one's about population. The table shows the populations of the New York City and Los Angeles metropolitan regions from the census reports for 1950 through the year 2000. Assuming these linear trends continue, when will the populations of these regions be equal? What will that population be? Consider the table. We have New York City listed at the left in row 1, Los Angeles in row 2, and then for columns, 1950, 1960, all the way through at 10-year increments along with the census, right up until the year 2000. And then populations, filling in the cells in the table. First, consider what you know. You know the population data for 2 regions. Then consider what you need. You need the point in time when their populations will be the same. And so your plan, use a calculator to find linear regression models. Plot the models and find the point of intersection. Well, to simplify things, we can enter all the numbers as millions rounded to the nearest 100,000. For example, enter 12,911,994 as 12.9. We'll also let our input variable to represent years be years since 1950. Step 1. Enter the data into lists on your calculator. So we'll create a table of values with L1, L2, and L3 on a graphing calculator as shown here at the right, or recall this may be an even faster, easier, and more attractive process at desmos.com. In the case of Desmos, you would click the plus sign and select a table, and then fill in values very similarly to the steps you'll see here with these screenshots of what a graphing calculator may look like. So step 1, we'll let L1 be the number of years since 1950 and fill in those values. List 2 will be New York City's populations for each of those corresponding years, and L3, Los Angeles populations. Step 2, on a graphing calculator, we'll use linreg for linear regression, ax plus b, indicating that we want our equation in slope-intercept form, to find lines of best fit. On Desmos, we'll use the y sub 1 regressed against mx sub 1 plus b to find those same lines of best fit. On the graphing calculator, we'll use L1 and L2 for New York City, L1 and L3 for Los Angeles. On Desmos, we just have to carefully make sure we select the correct variables for our regression equations. Step 3, graph the linear regression lines. On a graphing calculator, they'll look like the screenshot at the right. And then on the graphing calculator, we'll use the intersect feature to calculate the point of intersection of the 2 lines. On Desmos, we'll simply zoom and pan until we find that intersection and click on it to reveal its coordinates. The x value of the point of intersection is about 87, which, remember, since we input our years as years since 1950, 87 represents the year 2037. The data suggests that the populations of the New York City and Los Angeles metropolitan regions will each be about 25.6 million in the year 2037. Your turn. The table shows the populations of the San Diego and Detroit metropolitan regions. When were the populations of these regions equal? What was that population? And here we have to assume this population growth is linear, at least for the purposes of this problem.